Welcome to this video. This video is for Cambridge A-Level Probability and Statistics 1, Paper 1, 9709 of October-November 2020. Coming to the first question. Two ordinary fade dice, one red and another one blue, are thrown. Event A is a score on the red die, is divisible by 3, and event B is the sum of the two scores is at least 9. So first of all, I am going to draw a table. Let me draw the table over there. So that I can get the answer. So it is 1, 1, 2, 3, 4, 5, 6. This is 1, this is for 2, this is for 3, this is for 4, and then 5 and 6. Then I have the event A is score on the red die. 1, 2, 3, 4, 5, 6. And event B is a, what is this? A blue die. 1, 2, 3, 4, 5, 6. Now I'm going to add them all. So it's going to be 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, then 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. Now event A is a score on the red die is divisible by 3. So which are the numbers divisible by 3? So I should be taking it out, this one, rather than this color. So I use a different color. So this is divisible by 3. It can be 3 or 6. So I have done for 3 or 6. Question, find A intersection B. What is the meaning of A intersection B? I should be getting it out, which is divisible by 3, and also it should be at least 9. So for that, what am I going to do? I am going to take the numbers which are divisible by 3 and at least 9. So we can see that it happens over here. And how many such numbers are there? 1, 2, 3, 4, 5. 5 numbers are there, 5 upon 36. Because there are totally 36 outcomes. So therefore the answer is going to be 5 upon 36. Hence determine whether or not A and B are independent or not. So for A and B are independent, so I have to calculate the concept. What is the concept for A and B to be independent? Probability of A intersection B should be equals to probability of A times probability of B. So probability of A intersection B was 5 upon 36. Probability of A. What is probability of A? The score on the red die is divisible by 3. So how many are divisible by 3? So on the red die, the score on the red die is divisible by 3. So which is 2 and 6. 3 and 6. So it is going to be 2 upon 6. And B, the sum of the two scores is at least 9. How many numbers are there which is at least the score is 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 numbers are there, 10 upon 36. Are they equal? They are not equal. So because this is 5 upon 36, whereas this is 5 upon 54. So they are not equal, so not independent. If they are equal, they are independent. If they are not equal, it is not independent. Next question number 2. The probability that a student at a large musical college plays a band is 0.6. He plays a band is 0.6. For a student who plays a band, the probability that she sings along the choir is 0.3. Plays a band is 0.6 and plays a choir is 0.3. For a student who does not place the band, so which is does not place a band, which will be 0.4. She sings in the choir is X. She sings in the choir will be X. So not in the choir will be 0.7. Not sings in the choir will be 1 minus X. The probability that a randomly chosen student does not sing in the choir is 0.58. Does not sings in the choir is either this one or this one is 0.58. So what does it become? 0.6 times 0.7. plus 0.4 times 1 minus x equals to 0.58. So this is 0.42 plus 0.4 minus 0.4x equals to 0.58. So from there, what should be, I should be able to get that value of 0.4x equals to 0.4x equals to 0.82 minus 0.58. So x equals to 0. This is 24 divided by 0.4. So x equals to 0.6. Two students from the college are chosen at random. Find the probability that both the students play in the band and both sing in the choir. So both are playing in the band. So first student is and both sing in the choir and is also in the choir. So and means times. This is band and choir. So this is for the first student. Now and for the second student also band and choir. So it's going to be same 0.6 times 0.3. This is for the second student. First student and second student. So 0.18 times 0.18, which is going to be 0.0324. Question number 3 is competing in a throwing event. A throw is counted as a success if the distance is achieved greater than 30 meters. The probability that Kayla will achieve a success on any throw is 0.25. Probability of success is 0.25, so probability of failure will be 0.75. Find the probability that Kayla takes more than 6 throws. She takes more than 6 throws to follow it out. So probability of x greater than 6, which is going to be nothing but what? 0.75 whole to the power of 6. So which is nothing but 0.178. Find the probability that for a random sample of 10 throws, Kayla achieves success at least 3 times. So n equals to 10 out of at least 3 times means probability of x greater than or equals to 3, which is difficult to do. So 1 minus probability of x equals to 0 minus probability of x equals to 1 minus probability of x equals to 2. That will be the best way. So 1 minus 10c0, 0.25 whole to the power of 0.25 whole to the power of 0, then 0.75 whole to the power of 10. She should be getting it out success. 0 pi whole to the power of 10 minus 10c1, 0.25 whole to the power of 1 and 0.75 whole to the power of 9 minus 10c2, 0.25 whole to the power of 2, 0.75 whole to the power of 8. So which is 1 minus 0.0563135 minus 0.1877117 minus 0.2815676. When you simplify that, you should be getting 0.474. Then question number 4. We have 7 questions. We are already there in question number 4. A random variable x takes each of the values 1, 2, 3, 4 with the probability 1 upon 4. Two independent values of x are chosen at random. If the two values of x are same, the random variable y takes that value. Otherwise, the y value is the larger of the value of x minus the smaller value of the x. Draw the probability distribution table. So that's a very tricky question. See carefully how to solve it. So it's going to be 1, 2, 3, 4. 1, 2, 3, 4 and 1, 2, 3, 4. Now what is that? If they are same, if the two values of x are same, the random variable y takes the value. 1, 1 means it's 1, 2, 2 will become 2, 3, 3 will become 3, 4, 4 will become 4. Otherwise, the value y is a larger value minus a smaller value. So in that case, if at all, it's going to be larger value minus smaller value. Then it becomes 2 minus 1 is 1, 3 minus 1 is 2, and 3. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 2 is 2. So it becomes 2, 1, 3, 1, and 3, 2, 1, 4. Find the probability distribution table. So now we can see that what are the values that y can take. Y can take the values 1, 2, 3, 4. It can take the values 1, 2, 3, and 4. So this is y, small y, and probability of y equals to y. 1, 2, 3, 4. So 1 is how many times? We can see that it is 7 times. So I'm going to erase this. 1 is how many times? It is going to be 7 times. So it is 7 upon 16. 2 is 5 upon 16. 3 is 3 upon 16. And 4 is 1 upon 16. Then find the value for probability of that y equals to 2 given that y is even. Y equals to 2 given that y is even. So probability of given that it is even. Even is nothing but what? 2 and 4. 2 and 4. So which is 5 upon 16 plus 1 upon 16. Probability of even, which is 5 upon 16 plus 1 upon 16. Out of that it should be 2. Probability of 2 and even. So out of 2 is nothing but how much? Only 5 upon 16. So simplify that, it should become 5 upon 6. The time in hours that Devin plays in his game machine each day is normally distributed with a mean 3.5 and standard deviation 0.9. Find the probability that a randomly chosen day Devin plays a game for more than 4.2 hours. Probability of x greater than 4.2. So which is probability of z greater than 4.2 minus 3.5 divided by 0.9, which is probability of z greater than 0.7778. So greater to lesser than 1 minus z less than 0.7778, which is going to be 1 minus 0.7818, which is going to be 0.218. On 90% of the days, Devin plays his game machine for more than t hours. Find the value of t. So probability of x greater than t is 90%. So probability of x less than t will be 10%. So probability of z less than t minus mu, which is 3.5 by sigma 0.9 equals to 0.1. But this value will not be there in the table. So subtract from 1. So it's not in table. If at all it is not in table, subtract from 1, then swap this one. So it becomes probability of z less than 3.5 minus t by 0.9 equals to 0.9. Now 3.5 minus t by 0.9, from the table it will become 1.282. So 3.5 minus t equals to 1.282 times 0.9. This gives me t value as 3.5 minus 1.282 times 0.9, which is 2.35. Calculate the estimate for the number of days in year 365 on which Davin plays on his games machine between 2.8 and 4.2 hours. So probability of x lies between 2.8 and 4.2. So what am I going to do? And the mean. What is the mean? Mean is 3.5. So mean is 3.5. So probability of x less than 4.2 minus probability of x less than 2.8. So it becomes probability of z less than 4.2 minus 4.2 minus 3.5 divided by 0.9 minus probability of z less than 2.8 minus 3.5 divided by 0.9. So we have done less than 4.2 already, greater than 4.2 we have done it out, so we can still try it out, does not matter. So probability of z less than 0.7 divided by 0.9 minus probability of z less than minus 0.7 divided by 0.9. So 0.7 divided by 0.9, 0.7 divided by 0.9 is 0.777. Probability of z less than 0.778 minus probability of z less than minus 0.778. So probability of z less than 0.778 minus 1 minus probability of z less than 0.778. So it becomes 0.778 when I see from the table. I will be checking the value, take out the table and check the value of 0.778. it should be giving me some answers. So three significant figures. So 0.778. 77 is 0.7794 and 8 is 24. So 7794 and 24. So it becomes plus 0.0024. It should be giving you 0.7818 minus 1 plus 0.7818. So this is going to be giving me the answer, final answer as 0.5636. Now, but this is for 1 day, but I want for 365 days. So number of days equals to 365 times 0.5636, which is going to be 205 days. So answer is 205. Question number 6. The times T minutes taken by 150 students to complete a particular challenge are summarized. Draw the cumulative frequency. So for 20, so we have to draw the axis first. So what am I going to do? I'm going to draw the axis first, x-axis, and then I'm going to draw the y-axis also. So 0, 10, 20, 30, 40, 50. So it's not completing. So what should I be able to do? I should, rather than take a smaller one, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Then over here, again it's going to be 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. For 20 it is 12. For 20 it is 12. Then for 30 it is 48. 30 it is 48. Then for 40 it is 106. For 30 it is 48. 30 it was 48. For 40 it is 106. 110, 120, 130. So we should go all the way till 150, 140 and 150. Then for 60, 134. For 60 it is 134, 134, and for 100 it is 150. For 100 it is 150. So I'm going to draw a cumulative frequency graph. Don't forget to write it out. This is cumulative frequency, and over here I should be writing time taken. Again in minutes. Take longer than. So take longer than, that's 24%. So rather than doing it out over here, so it becomes 24% means remaining is 76%. 76% of 150, which is 114. So coming to part B, 24% of the people take longer than to k minutes or longer to complete the challenge. So remaining will be 76%. 76% times 150, which is 114. So from 114, draw a line and drop it down. When I draw the line and drop it down, it is in between 40 and 50. So it's going to be 45 minutes. Calculate the estimate and the mean and the standard deviation for this one. So I'm going to calculate the mean and the standard deviation. So first of all, I have to calculate the frequencies. Frequencies will be 12, 36, 48 minus 12 is 36, then it is 58, then it is 28 and 16. So how do I calculate the mean? Mean is going to be 10 times 12 plus 25 times 36 plus 35 times 58 plus 50 times 28 plus 80 times 16 total divided by 150. Simplify that, you should be getting 38.2. Now variance, what am I going to do? For variance, copy this entire thing. So variance equals to divided by 150 minus mean square 38.2 whole square, but square this one, 10 square, 25 square, 35 square, 50 square and 80 square. So my answer is going to be 17 point, it's going to be 321.76. So what's going to be the standard deviation? Standard deviation is going to be square root of 321.76, which is 17.9. Find the number of different arrangements in a way of 10-letter words shopkeeper can be done in which all three E's are together. E, E, E. So is 1 unit. Remaining will be 7 alphabets, 7 units. So totally there will be 8 units. 8 factorial divided by 2 factorial. Why this 2 factorial? Because there will be 2 P's over here, which is going to be 20,160. Next one, find the number of different ways in which 10 letters words can be arranged so that P's are not next to each other. So P's are not next to each other. So first of all, I'll find total ways. Total ways is 10 factorial by 2 factorial times 3 factorial, which is 302,400 with P's together. 9 factorial by 3 factorial, 60,480. So not together will be 302,400 minus 60,480, which is going to be 241,920. Then last part, find the probability that a randomly chosen arrangement of 10-letter words has an E at the beginning and E at the end. So probability equals to E at beginning and at end divided by total ways. So E at the beginning and E at the end is 8 factorial divided by 2 factorial. By total ways is just now we have got it as 10 factorial by 2 factorial, 3 factorial, which is 1 upon 15. E at the beginning and E at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. E at the beginning, E at the end. So there are 8 places, 8 alphabets. It can be done in 8 factorial, but 2 p's will be there, therefore 8 factorial divided by 2 factorial. Then the next one is find the 4 letters are selected from 10 letters word. Find the probability that different selections if 4 letters include exactly one E, one P. So it can be P, E, E, it can be P, E and E, it can be P, E, and it can be no E's. In this case, it will be 5 will be left over. So 5C0, this is 5C1, this is 5C2, and this is 5C3. 1, 5, 10, and 10. Add them all, so answer is 26. That's going to be the way, because in that shopkeeper, I'm deleting P, E, E, P, E. So remaining how many are left over? 1, 2, 3, 4, 5 are left over. So therefore, that's going to be the answer. That completes the paper. See you in the next paper. Bye.